Hello there. Today we will talk about alternating current or AC in short. I'm sure all of us have sometimes plugged an electrical bulb in home socket and have seen how it comes to life just by a flick of a switch. Well, it's all thanks to alternating current or AC for short. But what exactly is AC? Alternating current is like a dance party of electrons. Instead of flowing in one direction, like in direct current (DC), electrons in AC flow back and forth, oscillating rhythmically. This rhythmic back and forth motion of electrons can be represented by a graph on time axis, with the y-axis on the graph corresponding to amplitude of electric current at a given time. It happens so that the resulting graph follows a sinusoidal pattern centered around zero amplitude, after which it changes its direction. This oscillation is what powers our homes, industries, hospitals, and many more. And then what generates an AC signal? It is produced through an electric generator. If we look inside a simplified electric generator, it consists of a rotating magnet at the center of the body, wound with electric wires. The rotating magnet produces sinusoidally varying magnetic field around the electric wires, consequently producing a similar sinusoidally varying alternating current. The orientation of a rotating magnetic field will determine the position of maxima and minima of alternating current. This can be illustrated with the shown animation where the alternating current starts with maximum amplitude, then goes to zero, then to its minimum, and finally to its maximum value after crossing zero in one cycle. Now let's talk about some of the characteristics of an AC signal. First, there is frequency. Just like a heartbeat measures the rhythm of life, frequency measures the rhythm of an AC signal. In order to understand what frequency is, let's first understand what does a cycle mean for an AC waveform. If we draw an AC waveform as shown, we can see that the waveform repeats itself after a certain time. This repeated pattern of an AC waveform is called one cycle of an AC waveform. Now the frequency will be the number of cycles that an AC waveform repeats in 1 second. It is measured in Hertz. In this example, the frequency of a shown waveform will be 2 Hz, as in 1 second, AC waveform has 2 cycles. AC waveforms can have various frequencies. For example, in many parts of the world, the frequency of an AC signal that is distributed in homes is 50 Hz. This means that the AC signal will complete 50 cycles in 1 second. Now let's talk about peak voltage and RMS voltage characteristics of an AC signal. Peak voltage is the maximum voltage of an AC signal in one cycle. Peak value of an AC signal occurs twice in a cycle, once in positive half cycle and second time in the negative half cycle of the waveform. Now as the waveform is centered around 0 volts, its average over a long period of time will be 0. That is why for AC signals we use a special kind of averaging. We first take the square of the waveform as drawn and then take its average. Once you take a square of a negative half cycle values, they will also become positive. The average of the resultant waveform is therefore non-zero and has a more significance in AC signals. This resultant average is called the root mean square or RMS value of an AC signal. It is the RMS value of alternating current that will determine how much effective power will be delivered to a resistive load. Finally, let's clarify the phase characteristics of an AC signal. Think of a phase as the timing or synchronization of different AC signals. Let's draw two AC waveforms. When two AC waves of the same frequency have their 0 points occurring at the same time, they are said to be in phase or in sync, like dancers moving to the same beat. But what happens when they are out of sync? Now let us consider another example of two AC signals which are 90-degree phase shifted with each other. This means that when peak of one signal appears, the other signal at the same time has zero amplitudes. The two signals are said to be out of phase, and we say that the signal A is leading the signal B by 90 degrees because the signal A peak appears earlier in time than compared to signal B. With out of phase signals, things can get very interesting. Out of phase waves, if summed, can either amplify or cancel each other depending upon their relationship. And there you have it. In today's video, I tried to explain in simple terms the concept of alternating current. If you liked this video, then I encourage you to show your appreciation by liking, sharing, and subscribing. Until our paths cross again, keep learning and remain energized. Thank you.